We are looking at Chapter 7, Logarithmic Functions of the sample exam. If you recall, some of the things we did here is we looked at the graphs and equations of log functions. We also changed from log form to exponential form and exponential form to logarithmic form. We had laws of logs. We also evaluated logs using a change of base formula. We solved exponential functions using logs. We also had some application problems. Exponential application problems, where we could use logs to solve for time. So that was Chapter 7. Which graph best represents 2 ln x? And so we have here, we have a logarithmic graph, logarithmic function. In B, this is an exponential function, so we know that that one's out. Because the A, remember, if you remember the form, we have y equals a ln x. And a, if it was a positive number, then it was an increasing log function. And if it was a negative number, then it would be a decreasing log function. A cannot be our option because it has a y-intercept. And we know that log functions do not have a y-intercept. We also, here we have a decreasing log function. And this one here is increasing. And so our answer would be D. What is log 32 base 3? Subtract 2 times log 4 base 3 as a single logarithm. And this identifies that we have to use the law of logs, the laws of logs, in order to simplify this. In our first step, we should take the 2 here in front and put it up here in the exponent. The power law we will use. Log 32 base 3 subtract log 4 squared base 3. This would give us log 32 base 3 subtract log 16 base 3. And so when we do that, we also use the quotient law, which says that when we are subtracting 2 logs with the same basis, then we could combine them by taking the quotient, 32 over 16, which would give us log 2 base 3. So let's evaluate a log. And there is a few ways to do this. We can do it using same basis. So if we set the expression equal to x and then changed it to exponential form, where this is the base and this is the exponent, this is the number, and we change it to exponential form, b to the power of e equals n, we would get 3 to the power of x equals 1 over 243. And because 1 over 243 can be written as a base of 3, that's 3 to the negative 5, then x would equal negative 5. Another option here is we learned a change of base formula, and that is that log x base a is equal to log x over log a. And we take the common logarithm of x divided by the common log of a. And you can calculate that, of course, because it's base 10. It's the log that's on your calculator. And so here, that will give us log of 1 over 243 divided by log of 3, which will also give us, when you put in your calculator, negative 5. So there's 2 methods to use here. Of course, changing the base and equating the exponents is maybe more convenient. What is the logarithmic form of c equals 5 to the power of d? So here we have to change it to log form. And we have it in exponential, and this is the b, this is the exponent that will equal the number. And so we have, our base is 5, so our base needs to go right here. 5 needs to go, b doesn't have a 5 in the base, and d doesn't have a 5 in the base. In our exponent we have d, and we know that that must be equal to d, and the only one that gives us that option is A. Solve for x. We may want to attempt to write 4 to the power of x plus 1 and 7 as something of the same basis. But it's not an option here. We have to, since obviously 4 cannot be written as a base, or 7 cannot be written as a base of 4, and they cannot be written as anything, any other basis where we can make the exponents equal to each other, as in Unit 6, or in Chapter 6 rather. We have to take the log of both sides here. Log of 4 to the power of x, the common log of both sides. And we're going to use the law of logs and bring the x plus 1 in front. That will give us x plus 1 times log 4 equals log 7. Since we're solving for x and it's being multiplied by log 4, I'm going to divide the other side by log 4. X plus 1 equals log 7 divided by log 4. And now, of course, x equals log 7 over log 4. Subtract 1. You may also, when you go from this step, you may also do this. You may multiply each, use distributive property and multiply by log 4. And then move the log 4 on this side. This will give us x log 4 is equal to log 7 subtract log 4. And since the log 4 is being multiplied by x, x would equal log 7 subtract log 4 over log 4. You may wish to put this in on your calculator and then put the answers, each of the 4 answers in on your calculator to determine which one give you the same. It is going to equal log 7 over log 4, subtract log 4 over log 4 if I break up the denominator, and log 4 over log 4 is equal to 1. So it is log 7 over log 4 subtract 1, which is B. So there's 2 methods you may have. I mean, this would be a more convenient method, but we've worked with solving exponential equations this way. The equation A of t equals the initial amount times 1/2 to the power of t over 3 represents a radioactive sample after 2 years. It's a half-life. How much time will it take for 15% of the sample to remain? Sorry. We have, well, 15% of the sample remains, and that means we're going to have 15, and it would initially have been 100. 1 over 2 to the power of t over 3. And when you do this, you'll see that you're going to divide both sides by 100. That'll give us 0.15, or the 15%, equals 1/2 to the power of t over 3. Now when we're solving for the exponent, we could write both numbers as a base of each other if that works. Or you could take the common log of both sides, which will always work. And now we use the power law and bring the t down in front, the t over 3. That will give us log of 0.15 equals t over 3 times log of 1/2. Since we're solving for t over 3, I'm going to divide both sides now by log of 1/2. this would give me 2.73696 equals t over 3. And so we multiply this by 3, then t would equal 8.2. This could also be a constructed response item in which they tell you that it's a half-life every 3 years, and you have to first write the equation and then solve. So this can be a possible constructed response item. Speaking of constructed response, we'll move on. Here we have a exponential equation, and so we're going to move the 8 to the power of x plus 1 to the other side, and that will give us 5x to the power of x subtract 1 is equal 8x plus 1. And now, since 5 and 8 can't be written as the same base as it is in Unit 6, you will have to take the common log of both sides. And then we use the quotient, or not the quotient law, the power law, and bring the x plus 1 then in front, and the x subtract 1 then in front. And we would have x subtract 1 multiplied by log 5, which will equal x plus 1 times log 8. Now we use the distributed property. This will give us x times log 5 subtract log 5. That's x times log 5 and 1 times log 5. And we have equals x log 8 plus log 8. If then now we're going to move the log 5 to this side with the log 8, and we're going to move the x times log 8 over here. This will give us x log 5 subtract x log 8, and that will equal log 8 plus log 5. And so if we take x outside, that will give us log 5 subtract log 8. That will equal log 8 plus log 5. Now, since x is multiplying by log 5 subtract log 8, then x will equal log 8 plus log 5 all over log 5 subtract log 8. So when we put this on our calculator, it will give us a negative, approximately, negative 7.848619. So here we have a word problem. The pH scale, the pH is common, also Richter scale is common, is used to measure acidity of solution. pH, P of x, is defined by the equation P of x equals negative log x, where the concentration of the hydrogen ions x is a solution. In a solution is measured in moles per liter. Black coffee has a pH of 5. So what is the hydrogen ion concentration? That means solve for x. So 5 goes in for the pH, equals negative log x. And we're going to move the negative on the other side. Negative 5 equals log x. And now we can change to an exponential form. This is base 10. So that would be 10 to the power of negative 5 will equal x. And here we have 0.00001 equals x. So x equals 0.00001 mole per liter. Baking soda then has a pH of 9. In terms of concentration, how much more acidic is black coffee than baking soda? And we already have black coffee. It's 10 to the negative 5. Baking soda would be 9 equals negative log x. Negative 9 equals log x. Same procedure. And of course, 10 to the negative 9 equals x when we change it to exponential form. So we have 10 to the negative 5, which is black coffee, divided by 10 to the negative 9. We're trying to compare how many times more acidic black coffee is than baking soda. And this will give us 10 to the 4, which is 10,000 times. So number 34 to 39 on the multiple choice on the public exam is from Chapter 7, Logarithmic Functions. The constructed response question will be number 57. Once again, I feel that it will be a B kind of type problem where you'll have a word problem, likely pH or Richter. And the other one will be exponential equations that you'll have to solve using the laws of logs.